Hi, I'm Annie, and I'll be presenting our work, Text2FX Harnessing Clap Embeddings for Text-Guided Audio Effects. As humans, we're naturally great at describing sounds using concepts. For example, if we hear this original guitar riff, then this modified version, we might say it sounds bright. Another might sound warm and mellow, or even might sound underwater. Currently, if we want to make a sound tinny or crunchy, we rely on audio effects. But here's the challenge. Many audio effect controls are based on technical digital signal processing parameters, which can be complex and unintuitive for non-experts. Even for professionals, fine-tuning these parameters to achieve a desired sound can be time-consuming. This often leads to a disconnect between intuition and implementation, where we know we can use audio effects to make that transformation, but it's not clear how to set the controls of the audio effects to reach the goal. Semantic audio production seeks to bridge this gap by linking high-level descriptors, for example, old-time telephone, to low-level signal processing parameters, for example, the controls of a parametric EQ. To be effective, a semantic audio tool must not only generate meaningful effect parameters for a wide variety of text prompts, but also allow users to refine them according to their individual preferences. However, prior work in this area has faced several limitations. Systems typically handle only a single audio effect. They use small, closed vocabularies and cannot handle arbitrary text instructions, or they function as black boxes, altering the sound without giving users control to tweak the results. Introducing our solution, Text2FX, a method that leverages a pre-trained text audio embedder to control standard audio effects with descriptions of the desired outcome, like make it warm, in your face and bold, or old-timey radio. Text2FX has an open vocabulary and handles arbitrary English phrases without retraining. Text2FX sets the controls of the effects to make the described change to the sound. Since Text2FX uses standard audio effects, the users can then tweak the effect settings using the traditional interface. Any audio effect with a differentiable implementation can be added, all without training. Let's take a high-level look at how Text2FX operates. We start with a clean input sound. Next, we specify a target text descriptor, in this case, make it sound like it's on a 1920s radio. The inputs are then processed through Text2FX using a predefined effects chain. Here, we're just setting EQ to reverb, but any effects chain can be set. For example, EQ to delay to reverb to compression. Text2FX then outputs the modified sound, along with the exact effect parameters used in the transformation, allowing users to further tweak and refine the results to their preference. Here's another example generated by Text2FX. In this case, we've set the effects chain to reverb only, and we want to make our input sound underwater. We'll put the input and target text through Text2FX, which will then return the transformed audio, as well as the effect parameters applied to alter it. For more listening examples, please visit our demo page. Now I'll walk through our proposed method, optimizing effect parameters by steering clap embeddings. Our approach begins with a target prompt describing the desired transformation, for example, bright. We then apply randomly selected parameter settings to each effect in the designated effects chain, for example, EQ to reverb, or in this case, just EQ. Both the modified audio and the target prompt are then passed through Clap, a pre-trained text audio embedder, to generate embeddings within a shared text audio embedding space. Using gradient-based optimization, we iteratively adjust the effect parameters to move the audio's embedding closer to the target's position in the embedding space. Then we rinse and repeat. At the end of this process, Text2FX outputs optimized effect parameters, which remain fully interpretable and adjustable by the user. We call this single instance optimization via clap tuning. Here's an example of the optimization process, where the text target is bright, showing the progression to the final optimization result. We demonstrate that by repurposing the pre-trained clap model and using differentiable audio effects, we enable text-driven audio transformations with any text input and any effect or effects chains, without requiring additional model training. We additionally note that while we demonstrate our method using clap, the approach can be applied to any shared text audio embedder. Similarly, Text2FX can be used to control any audio effect or combination of effects as long as they are implemented differentiably. Thanks for checking out Text2FX. You can find our paper as well as the demo page with code via the QR codes displayed here.